Today we're going to be talking about section 3.2, which is on solving systems of inequalities by graphing. Now to this point we've talked about solving systems of equations by graphing, and what we did then is we graphed both linear equations, saw where the point of intersection was, and that's the solution that works for both equations. Now inequalities, you'll remember when we graphed those, they had a shaded area or a shaded boundary, and that was all possible solutions for that inequality. A system of inequalities is no different. We solve or we graph each inequality and shade the boundary, but now what happens is there's going to be an area on your graph that's shaded more than one time, and that would be the solution those would be the solutions that work for all of our inequalities. Okay, so you'll see right there the steps. First one, graph each inequality and shade the correct area, and then step 2 is to identify the region that's shaded for all of them, and that's the solution set. Those are all possible solutions for your system. Now if I look at example 1, it says solve the system of inequalities by graphing. So now I look at the first one, y is greater than 2x minus 4. I'm going to do that in green. Now you'll see that it's already in slope-intercept form, so I don't have to change it so it looks like that, where y is on one side, everything else is on the other. So what I'm going to do is I start at negative 4. There's negative 4. Slope is 2, so I go up 2 over 1. Up 2 over 1. I could also go down 2, back 1. Down 2, back 1. I look at my symbol. It's a greater than symbol. Since there's no line underneath it, it's not equal to, so that's a dotted line. Now, I have to figure out if I'm going to shade above or below. Two different ways to do it. First one, I'd say, okay, it's greater than. So most of the time that means I'm shading above. The other is to pick a point. So I'll pick the point 0, 0. So I put 0 in for y is greater than 2 times 0 is 0 minus 4. Is 0 greater than negative 4? It is, which means I have to shade that region. Now what I like to do is I like to pick either a colored pencil or something like that so that I know I can shade an area that's above or below it. So I shade above mine right here, and I'm going to shade it in green. This is like crayon or colored pencil. You can pick that as well. Okay, so I shade right there, okay, above my graph. Right? Now, I'm going to look at the bottom one, and I'm going to pick blue for that one. Y is less than or equal to negative 1/2 x plus 3. So I start at 3, and my slope is negative 1/2. So I go down 1 over 2, down 1 over 2, down 1 over 2, or I could go up 1 and back 2. So you see I have a line right there. I see my symbol is less than or equal to. Since it's equal to, it's a solid line. And we have to figure out which way we're going to shade. Less than, which means we generally shade below, but also if we put the point 0, 0 in there, 0 is less than or equal to 3, which is true. So I'm going to shade below it. And you'll see that there is one area that's actually shaded by both green and blue. And it would be this region right here. So that is actually the boundary area that's points that work for both inequalities. Okay? So we could actually try a point. Let's try negative 3, 0. Okay? So I'm going to try this point right here. Okay? Just to make sure it works. So if I put 0 in for y in the first one, I get 0 is greater than 2 times negative 3 minus 4. Well, 2 times negative 3 is negative 6. Minus 4 would be negative 10. Is 0 greater than negative 10? It is. So it works for the first one. Let's try the bottom one. I put 0 in for y. Is less than or equal to negative 0.5 times negative 3 plus 3. Well, negative 0.5 times 3 is going to be a positive 1.5 plus 3. And so that's actually going to be 4.5. Is 0 less than or equal to 4.5? It is. So it works for the bottom one. So we see that area right there that's shaded in both blue and green is the boundary and solution set for my system of linear inequalities. Here's a couple that you can try as well. Alright? So, it's possible that regions do not intersect. When this occurs, there is no solution, or you can call it the empty set. Okay? So if I look at this one right here, okay, I need to graph this one. Now, unfortunately, I don't have a graph drawn, so I'm going to have to draw one myself. Okay, so I will do the first one in green. Okay, and you'll notice I pick kind of the same colors all the time because you probably are going to have two colored pencils for you, and so you can just do them all the same color. That's fine. So y is greater than or equal to x plus 5. Okay, so I start at 5, and I have a slope of 1. So I go up 1 over 1. I can also go down 1, back 1. It is a solid line, and it's greater than. And so if I try 0, 0, I get 0 is greater than or equal to 5, which is not true. So I'm going to shade above. I take my green colored pencil, and I shade above. Okay? Now I look at the next one. Okay? Y is less than x minus 4. So I start at negative 4, and I have a slope of 1, so same slope, that's good. Okay? Now you'll notice, okay, dotted line, and shade below. Less than, okay, if I tried 0, 0, I get 0 is less than negative 4, which is not true. And so you'll see right here. So what happens? Well, what ends up happening is that I shaded the top of one and the bottom of the other. Those two lines are parallel. You'll see that their slopes are the exact same, right? 1 and 1, same slope. Okay, and I shaded opposite direction. So there's going to be no area that it's shaded both times. So this would be no solution. Here's a couple guided practice problems that you can try as well. We can also use this information to solve word problems. So here's an example of one. It says Chelsea has final exams in calculus, physics, and history. She has up to 25 hours to study for her exams. She plans to spend studying history for 2 hours. She needs to spend at least 7 hours studying calculus, but over 14 is too much. And she hopes to spend between 8 and 12 hours on physics. Write and graph a system of inequalities to represent this situation. So what we can do is we can look at each one independently. So the first thing is it says calculus. Okay, so we'll say calculus. We'll call that C. And it has to be between 7, at least 7, but no more than 14. So it'd be 7 is less than or equal to C. C for calculus. But it's got to be less than or equal to 14. 14 is too much. Okay. Then we also have physics. Okay, physics is going to be, it says between 8 and 12. So 8 and 12. Okay. And then it says that she has up to 25 hours. Well, already 2 hours of that is for history, right? So we can take 2 hours away. And so that means that the calculus in physics has to be less than or equal to 23 hours. Okay? So now we have a system of linear inequalities right there. And what we can end up doing is we can graph this to figure out the right amount of time for everything for calculus and physics. Okay, since we already know it's 2 hours for history. So I'm going to make an L graph, and on the bottom I'm going to put physics, and on the side I'm going to put calculus. Okay, and so with 15 for physics, 15 for calculus. Okay, so if I look at calculus right here, I'll do that in blue. It's between 7 and 14. So I go to 7, okay, and I make a straight line right there, and I go up to 14, right there. Okay, so this shaded region, I'll do that in my blue pen. Okay, that right there represents the amount of time she can spend on calculus. Okay, now let's look at physics. Well, that's between 8 and 12. Okay. Right there. Okay. Okay, so we see an area right there that's shaded in both blue and green, so that's physics and that. But altogether, it has to be less than or equal to 23, right? So what I'm going to do is I'm going to take another color, and I'm going to graph that. Okay, and so we'll say, let's see, y, so that'd be the c, has got to be less than or equal to negative p plus 23. Okay, so if we think of that in x and y, it starts at 23, which would be like up here, and I go down 1 over 1, down 1 over 1, down 1 over 1. Okay, and so it's going to be like that. And then it's got to be less than that, so I'm going to shade that again in a different color. And so you'll see that there's one area that's shaded completely in blue, green, and black. It's this area right here. And so all of the values within this point right here are possible values that work for all three of my inequalities. Okay? So an example of that would be, let's see, 10 hours of physics and 10 hours, right? Okay, I'll do that right here. 10 hours of physics, 10 hours of calculus, and then 2 hours of history. All that's 22 hours, which is less than or equal to 25 total hours. So this is how we can do this problem right here. Okay, you could try one right now. All right, so the last thing we're going to talk about is called boundary. Okay, and we can find vertices. These vertices are where these boundaries meet. Okay, and then the boundary overall is going to be everything shaded among them. And normally these boundaries form some sort of polygon. So here's an example that we can try. We'll start by graphing all three of our inequalities. First one I'll do in blue. Y is greater than or equal to 2x minus 8. Nice thing is that's already in slope-intercept form. So I start down at negative 8. Okay. And I have a slope of 2. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Solid line. Okay. Right there. And it's greater than, so I'm going to shade above. Get everything above blue. Next one. Here's one in red. Okay, so we start at 6. Okay, and we have a slope of negative 1/4. Okay, solid line. And then that one is shaded below. So it's all of this. We already see one region that's shaded in both colors. We have a third inequality right here. Unfortunately, this one is not in slope-intercept form. So what we're going to do is we're going to divide everything by 4, and we get y is greater than or equal to negative 15/4 x minus 8. So I start down at negative 8 again, and I have a slope of negative 15/4. So I can't go down 15 over 4. So I'm going to go up 15. And then back 4. Okay. And that one is greater than, so I'm going to shade above it. Okay, so we see our boundary that's created that includes all three colors. It's these ones right here. Okay, so now they're asking us to find our vertices. Okay, so here's one right here that's both blue and green. Okay, that's the point 0, negative 8. That's an easy one. Then we got one right here. That's going to be negative 4 and 7. But the last one you'll see is not really on a point. Okay, so for that one, what we're going to have to do is we're going to set the, okay, we see where the blue and the red cross. We're going to set the blue and the red equations equal to each other and solve for x and y. Okay, so we have, we're going to write 2x minus 8 is equal to, because we're trying to find where they're equal, negative 1/4 x plus 6. Okay, this is a straight moron problem, so what I'm going to do is I'm going to add 1/4 x to both sides. I get 2.25x minus 8 is equal to 6. Add 8. I get x is equal to 2.25x is equal to 14. Divide by 2.25. Find that x is equal to approximately 6.2. Okay? Once we know what x is, we can plug it back in, either one for y. So let's put it back into this one right here. Okay, so 2 times 6.2 is going to be 12.4 minus 8. And so then that ends up being 4.4. So the last point, the last vertex is going to be 6.2